Hello, my name is Harvey. I have been the project manager for Citywide Mechanical during our contract with Hunt Building Corporation for the installation of the heating and air conditioning system for the unaccompanied officers' quarters at Fort Leonard Wood, Missouri. We at Citywide have prepared a video to assist the owner, user in operating and maintaining this heating and air conditioning equipment. Now let's look at an outline of the program that we're going to discuss. We will give you a condensed overview of the type of system that we've installed. We'll discuss the chillers, the boilers, the pumps, the fan coil units, and the controls. The controls, we will discuss the thermostatic operation of the fan coil units, as well as a changeover system. We have made this video into two parts. First, we will give you a textbook coverage of the pieces of equipment and as they are described and pointed out in our O&M manual. Then we will go to the field and actually demonstrate the items on the pieces of equipment as we have discussed and as we've talked about. We have installed a two-pipe chilled hot water central plant system. The two pipes being one supply, two return line. We pump hot water from the boilers through the pumps into the buildings for the wintertime operation. In the summertime, of course, it's from the chillers through the pumps and into the buildings. The heating and cooling media is a 50% mixture of water and ethylene glycol. In the buildings are fan coil units. In the room units, most of them are floor-mounted cabinet style. In the laundry room, storage room, wet room, we have a horizontal ceiling suspended type of fan coil unit. Let's look at our chill water operating system. We have used two trained 100-ton air-cooled chillers. These are package machines using semi-hermetic reciprocating compressors. Each chiller is designed to cool 211 GPM of water antifreeze mixture to 45 degrees on its way, pumping it into the fan coil units in the buildings. The chillers operate automatically when enabled to run from the system control panel, which coordinates the overall system functions. Later, we'll discuss this control panel in more detail later. Each chiller has its own unit operating panel, which is located on a system panel inside the control circuit section of the cabinet of the access cabinet of the chiller. On this panel are the various service switches and fuses for control of the unit's compressors, fans, control circuits, etc., including the unit's main service switch, which starts or stops the chillers. These switches and fuses are described thoroughly on pages 7 and 8 of the operating and maintenance manual. Also included on this panel is a convenience outlet plug for using plug-in 120-volt tools, lights, and so forth. The chillers use a solid-state microcompressor electronic controller to maintain a selected chill water leaving temperature. The desired leaving water temperature is selected by setting the leaving fluid set point dial. The chillers operate with a multiple stage capacity ability by loading and unloading. The unloaders are solenoid actuated and discharge pressure operated. There are numerous operational safety controls to be aware of. These are outlined and discussed thoroughly in the operating and maintenance manual on pages 22 through 29. These are safeties such as the compressor motor protectors, three-phase power line monitor. This is a device that protects the compressor from single phasing or from trying to single phase in case one leg falls out. a chill water flow switch, an evaporator freeze protection switch, a compressor anti-recycle protector, and high pressure switches. These are all very important items in the routine operation of the chillers. Let's look at our operations manual in the chiller section on page 41. They've included an operator's maintenance log. We strongly recommend that whoever attends to the equipment use this as a guideline for their weekly, monthly, whatever routine inspection visits. The chart actually shows a weekly maintenance inspection. It gives a checkpoint block to register the conditions for the compressors 1, compressors 2, the refrigerant pressures, suction, discharge, the oil level. There is a place for the condition of the sight glasses on each refrigerant circuit, and also a place on the side over here for the entering and leaving chill water temperature. We found that these logs can be very valuable over a period of time for service people to understand how their equipment is operating, at what time of the year the equipment is running at what kind of conditions. This type of a log can be invaluable for a reference point later on. Now, on page 33 in the same operations manual, there are several pages in here of a troubleshooting breakdown, items to go check and see after conditions are found, a brief description of what the symptom is, the possible probable cause, and recommended action. There's several pages here, compressor conditions, running conditions of the compressors. If the compressor fails to start, compressor's noisy. As I've said, there's 2 or 3 pages here, and this is a real good, simple, basic key to try to understand what is going on if something out of the unusual or abnormal occurs. For the wintertime operation, we have used 2 Weil McLean. They are packaged cast iron sectional boilers, 2 million BTU input each. These are forced draft boilers. The fuel is low pressure propane gas. And like the chill water system, through automatic changeover valves, we are pumping water from the boilers through the pumps into the building fan coil units. These boilers have a series of burner controllers. These controls consist of a high-low fire operation, an electric gas ignition, an indoor-outdoor reset temperature controller. The boilers have an electrode-type low-water cutoff safety and an ASME-rated pressure relief valve. Starting and operation of the boilers is automatic. To enable the boilers to fire is through the main control panel, as with the chillers. Upon demand to fire, the blower starts and purges the boiler burner section for approximately 1.5 minutes. The burner then is ignited by the electric pilot. Low fire operation occurs for approximately 30 seconds to 1 minute, and then high fire burning comes on. Each boiler has its own temperature controller that sets the fixed water temperature that the boiler tries to maintain. These are adjustable. Also, each boiler has a gas manifold pressure indicator that's visible. We'll look at that when we go to each boiler. On the boilers, let's look on page 10 under the Boiler Operations Manual. We find several pages that gives instructions on starting, checking, adjusting. On page 10, we see a general pre-start checklist. The next page shows a burner startup checklist. On page 12 is fine-tuning the burner. Next page, gas burner adjustments. There is a complete list of wiring diagrams, specific information on the Honeywell, what we refer to as a fire eye flame guard controller. All kinds of parts information, specification sheets, complete detailed operating and instructions. Find the troubleshooting and maintenance page. The Wild McLean boiler people have done a good job in assembling a complete package of books that refers to each component that is used on their boilers. Our system, we have installed two 20 horsepower Payco base mounted horizontal split case pumps. The operations manual gives real clear information, instructions for several key things to check and to maintain with the operation of the pumps. First of all, obviously it's important to keep the lubrication, checking and following through with the alignment. Electrical connections always need to be checked routinely. The manual gives a complete replacements part guide, mechanical seal numbers, the train fan coil units. Again, in our operations manual, there is a section for the operation, installation, and maintenance on the fan coil units. The first part generally gives physical information, spec sheets, model numbers, sizes, so forth. Over towards the back on page 21, there's a maintenance suggestion checklist. The key things for a monthly basis to check are obviously the filters, either clean or replace them. Clean and inspect the drain pans. Drain pans always give a problem after accumulated use. It suggests every 6 months to oil the fan motors. Then on a yearly basis to check the electrical connections, check and clean if necessary the coils. Let's discuss our changeover procedure from chill water to hot water in the central plant. Here we see our system in the chill water mode going through the chillers, pumps into the buildings. From our main control panel in the equipment room, the systems can be changed from air conditioning or chill water to hot water. When we do this, valves will open either to the boilers, closing it from the chillers, or vice versa. Now we can see on our diagram that our system has now changed over into the heating mode. The control valves have stopped flow through the chillers, and we're now going through the boilers. There is another control on our hot water heating system that bypasses the boiler for minimum or mild weather operations. When full hot water is not needed, we bypass all or part of the waters to get an efficient firing operation from the boiler. The systems change over automatically, but I would like to take a second here to explain how important it is to allow enough time from changeover from heating to cooling or vice versa. There are controllers that sense the water temperatures that will not allow hot water to be put into the chillers or too cold of water from the chillers to be put into the boilers. There should be enough time given, and we recommend at least a day, 24 hours of continuous pump running without either the boiler being fired or the chillers being on, to allow the water temperature to neutralize and settle out before we go to the control panel and push the either enable chiller switch or enable boiler switch. When that is done, the valves will automatically change from cooling to heating depending on which mode is selected. That concludes our textbook session in our operating and maintenance session. Next, we'll take you to the field and get a hands-on demonstration of most of the items that we've talked about, particularly the chillers, boilers, pumps. We'll talk about the thermostats on the fan coil units in the buildings. We'll look at the building program timers as well. We are now at the project site at Fort Leonard Wood. The small building in the middle is the lounge club building. This is one of the 4 PLU living unit quarters buildings. We're looking now at the equipment room building, the building that houses our central plant. Inside the building are the 2 million BTU Wild McLean boilers and 2 circulating pumps. Beside the building are 2 air-cooled train chillers. The condensing section is a flat slab type coil that is behind the row of louvered access panels. The gentleman that's removing one of those panels is Garrett. He has been our project engineer through the entire course of this installation. We're filming this video in mid-December after a recent snowstorm. Obvious snow everywhere. On top of these chillers are 12 fans which provides the condensing air over the coil. In the summertime operation, these fans will cycle off as necessary to maintain. We're now looking at into the control panel at the end of one of the chillers. As we discussed earlier, in this control panel are the unit service switches, all the operating control components. I'll move in a little bit closer to illustrate some of these switches. Roy, if you would point out the unit's main service switch. That turns the unit on and off. We're now looking at the leaving fluid temperature set point dial. There's 3 dials there. The top one, Roy, indicate the top is the leaving fluid temperature set point. The next dial there is the design temperature difference. The bottom one, what is the bottom one, Roy? I can't see it.
Number of stages.
Yeah, right. That's the number of stages that the chiller will perform. The little dots, vertical row of dots to the right of that are the compressor stages LED lights.
Wonderful, Mark.
Roy, if you would point out the compressor service switches. Compressor 1 service switch, compressor 2 service switch.
Wonderful, Mark.
We can see right in the center there is a 120 volt convenience plug for lights, tools, and whatever. Inside this control panel are the condenser fan contactors, circuit fuses, all the basic electrical components for operating this chiller. Here on the side, as we see, inlet, water return inlet, and a water outlet leaving water. The flow switch on the next to the ground, yeah, there it is, the flow switch on the leaving water pipe. Inside the control panel, this is the heartbeat of the chiller. As we mentioned before, there's 2 compressors. We want to look at now there's 3 gauges in here that we talked about for our maintenance routine inspections. The gauge on the left is the suction pressure gauge. In operation, the suction pressures normally should be somewhere between 55 and 70 pounds as read on the gauge. The other end of the compressor are 2 other gauges. One on the right is the oil pressure. It should be somewhere around 20 pounds higher than the suction. The gauge on the left of the oil pressure is a discharge gauge, discharge pressure. That should be somewhere in the range of 250 to 300 pounds in normal operation. Roy, I want to point out where that oil level sight glass is. It's behind that center post. Yeah, there it is. We're now in the mechanical building. We're looking at the front face of our main control panel. This panel houses the switches that turns our pumps off and on, and turns our chillers off and on. Below this panel is the train sequence panel. This panel is used for multiple connections, multiple installations of chillers. It coordinates the operation of chiller 1 and chiller 2 into one unit. Roy, open up the door now and let's look at the switches inside this chiller. We've got two service switches there, and Roy's going to explain to us now how to actually put the system in operation for chill water use.
Switch the heat cool switch on the control panel. Two, you the chillers, you enable those, and you come down here to this panel on the controller switch. You switch it to on and leave it for 5 minutes. Then switch the other switch to run, and it will take care of itself.
We're now looking at our two Wild McLean 2 million BTU input boilers. It's a close-up view of the low water cutoff. Of course, the pressure temperature gauge. Boiler burner control panel is this box. Having a focus back to the boiler burner control compartment. Got a little bit better focus now. That is the blower housing the blower motor. The actuator to the left of it dampers the amount of intake air to the blower as the boiler adjusts from low fire to high fire. Roy, if you would, demonstrate now how to fire the boilers.
Okay, on the control panel, same as chillers, you have two switches. You enable, then you'll show you have power over here. Then you switch this on, this enables the blower to come on first. It will run for approximately a minute and a half. Then the pilot will come on, and immediately this light right here will come on to show that the main burner is ignited.
As we said earlier, low fire will come on and run for how long, Roy?
Now it purges itself for a minute and a half before the pilot comes on.
When it starts into fire, it's low fire.
Yeah, but when the pilot is lit, when it starts on, when this light comes on, it goes on to low fire. And maybe thereafter you can watch this arm move.
There's another gauge that we need to point out on these boilers. Each one of them has a gas manifold pressure gauge. Kind of getting that right in the middle of our screen there. This registers in inches of water column, and we've adjusted the burner fire to be approximately between 2.5 and 3 inches. Kind of getting an overall description of the piping system. Our valves are tagged. Located in the mechanical building, a framed valve identification schedule. This is a shot of one of our two automatic changeover valves. On our diagram, recalling these two valves, that's the other one on top of the elbow there, which is barely seen. These two valves automatically change over and allow water to flow from the boilers to the chiller. We're now in one of the typical room units. This is a typical floor-mounted fan coil that we're looking at. Roy, would you demonstrate how to take the cover off where the filter is?
Just grab it from the bottom and lift up. Here's the filter right here. It just slips out and slips right back in. These can be changed without taking the door off.
Oh, they can?
Yeah.
Now I want to change positions and get over here where I can see the three-way valve. All right. Let me see if I can zoom in on the three-way valve there. Roy, if you would point that out, I don't know how clear.
This is it right here behind this little
There we
sheet.
go. There we go. Now the clicks on Aquastat.
It's this red and white black wire. It goes right there.
There are hand valves on the supply and return chilled and hot water pipes that can be valved. Each unit can be valved off. There's a manual air bleed at the top of the coil, top right-hand portion of the coil. Roy, indicate where that manual bleed is. Yeah, right there. Got a shot now of the fan motor. We talked in the other day about our maintenance, routine maintenance checks, oil in the fan motors.
Right there.
Two oil entry ports there. Also onto the side over there, the little drain pan. It's obvious, of course, where that is and how to clean and inspect that. Also, each unit has a outside air damper motor. Well, if you can point that out. This damper motor opens to a minimum position to allow like 10% outside air to mix with return air on its way through the unit. That's easy to get to, easy accessible, can be changed easy. This is our typical room thermostat. The dial on the left has got a warmer or cooler selection point. The switches on the right, the system switch is on or off, and below it is a 3-speed fan switch. Since the thermostat has no subbase, the Aquastat that we pointed out in the fan coil a while ago senses the water temperature, either hot or cold, and tells the thermostat when to react on a temperature fall or a temperature rise. In other words, the Aquastat acts as a subbase to let the thermostat know when it's in the cooling season or in the heating season. This is a shot of a horizontal hanging unit. We're in one of the wet storage rooms now. This is a shot around of the same unit from kind of behind it and on the side of it. On the return duct side there, we can see a damper motor. This style of unit is this is a 2-pipe heating only unit. The damper motor allows 100% outside air when the fan is energized. The portion of the return grill that we can see to the side of the ductwork is blanked off such that the unit only gets outside air. It's another horizontal unit. We're now in one of the mud rooms. same type of unit. Again, it's a 2-pipe heating only, uses 100% outside air. All right, we're looking at a section of our piping, and again, we're in the mud room of building B. Our trunk lines rise up into the wall to the right, and in this room they split. 2 4-inch lines go to B, C and D, and 2 of them to A and B. And Roy, point out which lines are which now.
These go to A and B, and these 2 here go to C and D, and the lounge.
On B and C, they go across that breezeway on the way to B and C, don't they?
Yeah, through the lounge.
There's shut-off valves, of course, on each one of the lines, each one of the supply and return, so that portion of the system can be. We're looking at a fan coil unit now in the maze room in building B. The supply duct extends through the wall to the left out into the hallway. We're now looking at an energy control timer. Each one of the 4 buildings has got one of these control timers located in the maze room. This timer has many applicable functions. The main intent is to use the controller as a time clock. All of the PLU units are wired and interlocked into this timer such that all of them can be turned on and off at a designated time. In addition, this controller has got the ability to sense the outside air temperature as well as the inside room temperatures and compensate either earlier or later for system startup, depending on what the system needs to do at that particular time. The programming of this thing is done easily from inside. The control manuals, which we have left with you, give a step-by-step instruction procedures to how to program this controller. This concludes the film portion of the equipment orientation session. The heating and air conditioning equipment that we've installed will provide years of dependable and reliable service if maintained and operated in accordance with the instructions and manuals that we are leaving with you.